Assalamu alaikum, welcome to another experiment. So this is to determine the deflection in curved bars, quadrant, semicircle and circle. Usually all of them are quadrant, semicircle and circle. These are all parts of a circle, so all of them can be termed as curved bars. So in this lecture we are going to study their deflection, and we are going to see some formulas by which they behave. So these are some of the examples. This is a quadrant bar, this is a semicircle bar with which two dial gauges are connected. One is horizontal, the other is vertical. Similarly, you can see here with the quadrant, one is horizontal, the other one is vertical, with some weights hanging down, putting some force on them. So we have quadrant, semicircle and a circular ring having 300 mm dia each, with two sets of dial gauges. So this is how you are going to clamp it. The semicircle is going to be clamped at the bottom section only, just like this, with weight hanging and one horizontal and one vertical dial gauge. Similarly, the quadrant is going to be fixed at the bottom end with the vertical and horizontal dial gauges attached. Different increments of loadings are going to be put on these hangers, and their readings are going to be noted. This is a full circle ring as shown, where only the vertical displacement here we have to find out with the help of this hanger on which we are going to put some weights. This is another one. This is called as a single davit straight. Although we don't have it in on lab, but this can also be used in this experiment in the same way as we have used the semicircle and the quadrant. So these are some of the formulas. For horizontal displacement, we are going to use the formula delta H is equal to WR cube pi over 2EI. Here W is the weight that is going to be hung. R is the radius of the curvature. Pi is 22 by 7. E is the modulus of elasticity, which is different for different materials. For steel, aluminium and brass it is always different. I is the moment of inertia, which is the sectional property, and its vertical displacement is going to be delta V is equal to negative 2WR cube over EI. Similarly, for quadrant we have delta H is equal to negative WR cube over 2EI, where vertical displacement is WR cube pi over 4EI. So this is how we are going to tabulate our data. Weight, measured horizontal deflection. Measured horizontal deflection is the horizontal deflection we get with the help of the formula. Measured vertical deflection with the help of formula. Theoretical horizontal deflection with the help of the horizontal dial gauge. Vertical deflection with the help of the vertical dial gauge and their percentage difference. So these are some sample calculations. For example, if we have a quadrant curved bar and we are hanging 5 Newton weight with weight of the hanger as 0.5 Newton and radius as 150 mm, and W is equal to 210,000 Newton per mm square. I is equal to 56.25 mm power 4. I think 210,000 Newton per mm square. This is, I think it is steel. I don't know. We have to confirm it. So delta HB horizontal displacement is equal to negative WR cube over 2EI, which comes out to be 0.786 mm. Vertical comes out to be negative WR cube pi by 4EI, which comes out to be 1.35 mm. So from experiment we have experimental which is given by the dial gauge. It comes out to be 0.85 mm. So theoretically it is 0.786, but experimentally it was 0.85. Similarly, the vertical deflection was 1.235, but what was recorded at lab was 1.5 mm. So their percentage difference is found by the formula theoretical minus actual by theoretical. So it comes out to be 8.14%, and the other one is 21.46%. So this data is coming out to be way more different than with respect to the horizontal, with respect to the theoretical and the experimental value. So this needs to be seen again. Similarly, for semicircular bar, if again we have 6 Newton weight, 0.5 Newton weight angle, 150 mm radius, 210,000 Newton per mm square E, and I is 56.25 mm power 4. Again, using the same formulas for theoretical, the theoretical horizontal displacement comes out to be 3.71 mm, whereas the theoretical vertical displacement comes out to be 2.918 mm. So from the experiment, we have the experimental value as 3.28 mm and vertical as 3.01 mm. Their percentage difference come out to be 11.59 and 3.15. So this value is way more agreeable than this one. So again, if we have a circular bar and we use the same procedure, W is equal to 15 Newton, again adding the weight in increments. So this come out to be the percentage difference, vertical percentage difference come out to be 13.76%. So again, you can note that here we only have the vertical displacement in here and no horizontal displacement, because as we have already discussed, the full circle, it only has a vertical dial gauge. It cannot have a horizontal dial gauge. So that's it for today's lecture. I hope you all are going to learn something from it. For any queries, you feel free to contact me in the comments section below. Thank you so much.